Hello everyone and welcome back to another competitive programming video. Today we're going to be taking a look at a British Informatics Olympiad question taken from the 2014 paper. So let's have a look at the question. So the question states that lucky numbers are produced by taking a list of all the odd numbers and systematically removing some of the numbers. Our first lucky number is 1, and we now take the next highest, n, that is still in the list, mark it with the lucky number, and then remove nth number from the list. So let's basically have a look at that example. So the first line says like all the initial odd numbers which we have, and then the first lucky number is 1, but then we don't remove every one digit. We take the next highest number, which is 3, which comes after 1, and then we remove every third digit. So then the third digit would be 5. So that's gone, and then after that, the third digit would be 11, that's also gone, 17, etc. And now we basically just repeat the process. So it would be, the next number would be 7 after 3, since 5 has been removed. And then we'd remove every 7th number. So we'd remove, the first one is 1, then it's 3, 7, 9, 13, 15, and then 21. And then 19. So then we'd remove 19, then so on. So something to bear in mind is that the third number and the 7th number, they won't necessarily be the same as the original position. For example, in our original odd numbers array, the 7th number would be 13. However, on the third line you can see the 7th number is actually 19. The reason for this is obviously because some numbers have been removed, like 5, which affects the index of the other numbers. And our job is to produce the closest lucky number, which is less than the input, and the closest lucky number, which is greater than the input. And you can see the inputs are quite small, like only up to 10,000, which means pretty much any brute force code would work here. So let's just have a quick look at the program. So we initially just create the array of the first 5,000 or so odd numbers. I've chosen 5005 because if I chose exactly 5,000, then there's a chance that I wouldn't include some of the 10,000 ones. So I might as well just go a bit beyond the first couple of 5,000 odd numbers. And then after that, I initialize the variable current to being 3. We'll come onto exactly what current does a bit later. But now, as you can see, lines 3 to 8 are basically this while loop. So initially, in line 4, I have this particular list combination. So what this does is that it basically means that every number which is of an index, which is a multiple of current, that number will be removed from the array. So let me just walk you through this line. So I for I in range len r, so this basically loops through every index. If I plus 1 mod current not equals 0. So I plus 1 is basically the index, but 1 based. Since remember Python has 0 based indexing, but I plus 1 would be the 1 based indexing. Because for example, let's say we go on to the second line here, the third number is 5, that would have an index of 2, but then for us to know that it's the multiple of the third number, we would need to do its index 2 plus 1. And then likewise for 11, it would have index 5, then we do we would have index 5, then we have to do index 5 plus 1, which would be 6, which would be a multiple of 3, therefore we remove it. That's basically what this line does. And then after that, what we do is we basically have this try except block. The reason for this is because this basically gets the index of the next lucky number, but then the reason why it's in try except is because in case there are no more indices left, then the program will just error since that particular number does not exist. So this is basically why there's try except. If it were an if block or something, but I would just recommend just do this, but it's a bit easier just to implement. And now all of this just generates the array of lucky numbers. And now we're accepting the input. So let's say the input's 5 or whatever. Then that will be where our looking numbers will be start from. So prev, I'm initializing this variable prev, stands for previous. The first element is the array, and then I loop through each element inside the array, assigning the previous element to L if A is not equal to L. A is the input, okay? And this loop basically just iterates through all the numbers until we've found our selected number. And then we need to keep track of what the previous number is. So each time the number which we inputted is not equal to the number which we're currently iterating over, we're assigning that value to prev. So then the next iteration, as you can see over here, once we finally finish, we found an element which is greater, we can print the previous and the L. Okay? So it was also possible to implement all of these with the bisect module. So what the bisect module does is basically it gives you the index of the first element, which is less than the selected element, if you were to insert that element. Like I know that was a bit of a mouthful, so I'll just show you an example here. So let's say we would do the bisect left, or do the bisect left and bisect right. We would do the bisect left of this array. So then of 4. So if we were to insert 4, it would take the up index 4. So then it would basically give us index 4 as the answer for bisect left. And it would also be the same for bisect right, since it doesn't actually make a difference when you insert 4 in this case, since there's only one way to insert 4 to keep the list sorted. But then if we do the bisect left 3, that would give us index 2, since 3 would be inserted in this position. If we do bisect right, that would give us index 4, since 3 would be inserted in this position. We could have done bisect left and bisect right, but since the input's quite small, like this slightly less efficient code, which is much simpler to understand and implement, I just do that one here. So if we see on the sample input's 5, if we just type in 5, it gives us the right answer. And now if we try out some of the other ones, yes, this also gives us the right answer, 1923 and 1933. So yeah, that's basically it for today's video. I hope you enjoyed something, hopefully you learned something new about the question we're discussing. I hope you enjoyed the video, and see you next time. Thank you for watching. Bye.